This video will be about significant figures. So significant figures are used by chemists and other scientists in order to determine a better number for their data. This is because chemists and other scientists, they use calculations, while mathematicians just use numbers, so they can round it whenever they like. Significant figures have 5 rules. The first one is that all non-zero numbers are significant. What that means is that 1, 3, 7, 5, 2, all these numbers are significant because they actually hold value. The only non-significant number are 0, but there's many exceptions to that. The second rule is that any zero between two non-zeros are significant. So in number 7005, these two zeros, because they're between the 2, 7, and the 5, they're all significant. So this one has 4 significant figures. The third rule is that all zeros past the decimal point are significant. So in the number 25.00, these two zeros, because they're past this decimal point, they are significant. So this also has 4 significant figures. The fourth rule is that all zeros in front of numbers are not significant. So in the number 0.0029, these 3 zeros, because they're in front of these 2 numbers, they are not significant. So this only has 2 significant figures. The fifth and final rule is that zeros at the end of numbers without decimals are not significant. So what that means in the number 85,000, these 2 are just placeholders, so they have no significant value. Now it's time for examples. This number has 4 significant figures. It has 4 non-zero integers. This number has 2 non-zero integers, but has 1 0. But since the 0 is between the 2 non-zeros, it is significant, meaning this has 3 significant figures. This number has 5 numbers in it, but because there are only 2 non-zeros and there are 3 zeros, but the zeros are before the non-zeros, this only has the 2 significant figures because only these 2 numbers counted. For number 4, it has 3 significant figures because it has 2 non-zeros and 1 0, but the 0 follows the decimal point, so it is significant. Now the last example is kind of like the first example, in which all 3 of them are significant, meaning the end result is 3 significant figures. Do addition and subtraction, but with the correct number of sig figs, you have to record the answer with the least number of decimal places of the starting numbers. What that means is if you have 3 numbers, say like 90.2 plus 65.291 plus 12.38, this is around 167.871. 90.2 has 1 decimal place, 65.291 has 3 decimal places, while 12.38 has 2 decimal places. And because the rule is it's with the least number of decimal places, which is 1, the end result also only has to have 1 decimal place. So 167.9 is the final answer. For multiplying and dividing with sig figs, you take the least significant starting value and that becomes the significant figures of the answer. So if you have the number 13.78 and you divide it by 11.3, the answer is 1.219469. This one has 4 significant figures, while 11.3 only has 3. And because this is the least, the end result should also have 3 significant figures. So the final answer is 1.219 rounded, which is 1.22. And that is how to multiply and divide using sig figs. In chemistry, rounding numbers is the same as if you round numbers in math. What that means is that if the number ends with 4 or less, round to the nearest 0. And if it's 5 or greater, you just round up. Now it's time for some examples. The first one is division, which means you take the least number of sig figs. So this number has 6 sig figs, while this number only has 4. So that means the end result also has to have 4. And so we cut off right around here, but since it rounds, this rounds up to 2. The next one is multiplication, which is the same thing, and we need least number of sig figs. This has 4 sig figs, while this only has 3. So we take only 3 sig figs. So 56.0, that's exactly 3 sig figs. So that'll be the end answer. Now the third one's addition, which means you take the least number of decimal places. This one has 3 decimal places, this one has 2, meaning the end result also has to have 2 decimal places. So you cut off right here, but since it's a 7, this rounds up to a 3. For the fourth one, it's subtraction, so that you take the least number of decimal places again. So this has 3 decimal places, while this has 4, so least number is actually 3, which means the end answer cuts off here, but since it rounds, it becomes 214.199. And that is the answer. Last thing is with multiplication and others. So let's say you have the number 222, and you multiply it by 2. The end result is 444. But because of significant figures, we have to take the least sig fig, which is this one, which only has 1, while this one has 3. So we take the 1, and the 444 actually becomes only 400, because it needs to have 1 sig fig. So that's